Day 4, Problem 1. Daryl is enlarging a digital photograph on his computer. The original photo is 1.4 inches by 2.4 inches. If he enlarges the dimensions by scale factor 5, what will be the perimeter and area of the new image? Here is his original photograph, just a quick sketch of it. And we are told that it is 1.4 inches by 2.4 inches. He is going to transform this photograph. And the way he's transforming it is by enlarging it using a scale factor of 5. That means he's going to multiply these dimensions by 5, and that will create a larger photograph. So to find the width and height of this photograph, we can take these sizes and multiply by 5. Let's do that. So 1.4 times 5. 4 times 5 is 20. Carry 2. 1 times 5 is 5 plus 2 is 7. The decimal point here, that is 7.0, or just 7. Now for the height, 2.4 times 5. 4 times 5 is 20, carry 2. 2 times 5 is 10 plus 2 is 12. And the decimal point here, 12.0, or just 12. So on his computer, the new photo is 7 inches wide and 12 inches tall. And with those dimensions, we can find the perimeter and area. So let's start with perimeter. To find the perimeter of a rectangle, we need to take 2 times its length and add 2 times its width. That accounts for all 4 sides of the rectangle. And so that's going to be 2 times 12 plus 2 times 7. 2 times 12 is 24. 2 times 7 is 14. And adding these together, this is 38 inches. Now the area. To find the area of any rectangle shape, we can multiply its length times its width. And so that is 12 times 7, which is 84 square inches. So the distance around the outside of the rectangle is 38 inches, and the amount of space inside the rectangle is 84 square inches. Now, day 4, problem 2. A square pyramid has base with edges 5 inches long. Its height is 18 inches. Sketch a picture of this pyramid. To create the illusion of a three-dimensional object, even though the base is a square, we're going to draw it so that it looks more like a parallelogram, like this. Then locate the exact center of that base and move straight up above with your pencil to find the top of the pyramid. Connect the top of the pyramid to all 4 corners of the parallelogram. So like this, and then like this, and then like this, and then the 4th and final edge needs to be done as a dashed line because it's hidden through the solid three-dimensional object. Now for some labeling, we're told that the edges of the base are 5 inches, so this is 5 inches, and this is 5 inches. And the height, which is from the point to this dot in the center of the base, let's draw that in there, touching the bottom at a 90-degree angle, that is 18 inches. So 18 pointing right at that little dashed line. There is our picture. Now in part B, we can find the volume, or that is the amount of space inside that three-dimensional object, by using this math formula. So volume equals 1/3 times the area of the square base times the height. Because the base is a square, we can find its area by multiplying length times width, 5 times 5. Or another way to think of that, because it's a square, we can find its area by squaring one of the edges. 5 squared is 25. The height of the pyramid is 18. Now let's multiply these three numbers together. Multiplication is commutative, meaning it can be done in any order and you get the same result. Now, I think it will be faster to multiply 1/3 times the 18 first than to try to multiply 1/3 times 25. 1/3 times 18 will reduce. The 3 divides into 18 6 times. And then we can go 1 times 25 times 6. That is 150. Volume is measured in cubic units, so this is 150 cubic inches.